Okay, so now we are going to introduce a shortcut. So like I said at the end of the last video, what we were drawing was everything in the atom. You know, we had the nucleus with all the pieces, which I still shortcutted because I am a natural-born chemist, and then how all of the electrons are organized are on the outside. And then I introduced the idea of like, well, there's a valence shell, and then the inner electrons. Well, the inner electrons just sort of hang out. They don't perform any chemistry. They're always just associated with that nucleus. And it's those outer electrons that are going out, and maybe they're being shared or sent out, or maybe electrons are being added to that shell. We'll talk about how we know what's happening there later. But those are the types of things that can happen, and they're happening on the outside. And so really, all we need to talk about are the outside electrons. And so the Lewis dot structure has the chemical symbol. Instead of drawing a nucleus, we put a chemical symbol in the middle, and we surround with dots that represent our valence electrons. So we aren't drawing all the inner electrons. We aren't drawing our protons and our neutrons. We aren't even drawing a nucleus. We're just writing a letter or two. So for example, let's see, I started with hydrogen last time. Let's do that again. Alright. Well, if we look at our periodic table, we see that the chemical symbol for hydrogen is H. Oh, good. The Romans didn't know about that one. The letter makes sense. Alright. And then it has one electron, and it only has one shell, so that's its outermost shell. And so I just draw a dot. That's it. That is the Lewis dot representation. That's the whole thing. I have my element, I have my one valence electron accounted for. Now if I were to do something like, you know, I don't know, boron. Let's talk about boron some more. Alright. One of my favorite things about boron, there's a town called Boron, California, and I went there and I bought a boron t-shirt. There's your fun boron story. It's my least depressing thing I could say about the element. And it says boron, the original fifth element. So if you ever bought borax soap, they mine it there. Like they mine borax. That's what they do, and they're so proud they changed the name of the town to Boron. It's out in the desert there in California, between the Central Valley and Barstow somewhere. I don't know exactly, but I went there. All right, so boron. You know, we can look at it and be like, oh, well, there's 5 protons and it has a mass of 11, so that's 6 neutrons. Blah blah blah. We don't need any of that. We just go straight right to the letter. Okay. We just go, all right. That's a B. And then I look at my periodic table and I just count. I don't worry about the inner electrons. I only worry about the row of 10. I go 1, 2, 3. Now here's the trick. I don't want to pair any of these 3 dots. So I'm going to go 1, 2, 3. Alright. And that's it. Boron. If I want to know how many protons there are, I'll look at the periodic table. That tells me where to look. It has 3 valence electrons. This is where the chemistry is going to happen, those 3 dots. So that's all I got to worry about. Now let's take it, one more element up. So let's talk about carbon. Alright, carbon's element, it's over here. I mean, there's a big blow up here, but it's here. It's one more to the right of boron. And so, I'll have 1, 2, 3, 4 valence electrons. Chemical element of C. That's what I do. I don't want to pair any of these up. I want to have them all by themselves. You always go, up, down, left, right. Old Nintendo controller. That's how I describe it. Up, down, left, right. There's no diagonals. There ain't no Super Nintendo here. Okay? Now, we want to avoid pairing electrons until we have to. And when do we have to? The answer is as soon as there's more than 4. Okay? So if we look at nitrogen. Alright. We get over here. We're going to go one more to the right from carbon. So there's going to be 5 dots now. So chemical symbol of N. Alright. And we're going to go 1, 2, 3, 4, 5. So now there's a pair. Okay? There's 2 on the left. And I'm not going to be picky. You know, it doesn't matter. There's no right spot to put the pair. It can be up, it can be to the right, it can be down, doesn't matter. What you need are 3 unpaired electrons, 3 dots by themselves, and 2 dots together on a side. So don't have like 2, 2, and 1. You want 2, 1, 1, 1. However that works. And so like same with boron here, like there's an empty spot, right? And so that empty spot could be up, down, left, right. As long as these 3 electrons are separate from each other, you're good. That's all I'm looking for. So there's no rule about where the pair has to be if there's only one. And so let's do one more here. Let's look at, should we do oxygen or fluorine? Let's do oxygen. That's a more important biological element. Alright. Chemical symbol is O. And it has 1, 2, 3, 4, 5, 6 valence electrons, right? I don't know, my hand might have been 1, 2, 3, 4, 5, 6 valence electrons. So again, as we're going across, we're filling. And this row is going to fill with 8. We're not all the way to the end. There's still 2 more that we would need to fill it, so it's only got 6. Alright? And so we go chemical symbol, 1, 2, 3, 4, 5, 6. So there's 2 pairs and 2 individual. And again, it could be like this, or I'm not going to be particular. Any of these are fair game. You know, something like this. Anything like that, you know, etc. Okay? So 2 pairs, 2 unpaired. Don't do 3 pairs. Don't do pair, pair, pair. That's bad. That's wrong. Don't have a different number than 6. That's not going to be, that's going to be an ion. It's not going to be elemental oxygen. So that's wrong. So those are the mistakes you can make. So you don't have to worry about where individual and where pairs are. Just understand that, like, this is a valid representation of nitrogen. This is a valid representation of nitrogen. Oof. And this is a valid representation of nitrogen. There's a lot of syllables in those sentences, okay? Cut me some slack here. And any of those work. I don't care which one you draw. And if you see a digital representation of that, you know, on a question on, you know, through Moodle somewhere, those are all fair game. Now, I learned it from a math professor a long time ago. You don't ever draw something wrong, even as a demonstration. You just don't do it. You don't do it in front of class because someone's going to, like, remember it that way. So I'm describing what's wrong. But if it's unclear, ask me, you know, in a forum or an email. We can talk about it more. But essentially, you know, when I'm saying unpaired, I mean an electron that's up top by itself or to the right by itself or below. When I say paired, I mean 2 of them are on one side together. And so there should be 1 pair and then 3 unpaired. And there should be no blank spaces here. Because if you have any paired electrons, everything else needs at least 1 electron in it. So oxygen has 2 paired electrons, and that's because it went unpaired, 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 and then we still had 2 more to put in. And so then we start pairing. And so when you get to a noble gas, it's all paired electrons around it. So if we talk about neon, so if we go just to the end of this row here. Alright. Go all the way to the noble gas, to neon. It's going to have a full valence shell. It's going to have all 8 electrons. So what does that look like? Well, 1, 2, 3, 4, 5, 6, 7, 8. That's it. And there's only one way to draw that. There's no options here. It's 2, 2, 2, 2. 2 up, 2 down, 2 left, 2 right. 8 electrons. So that is how we draw the Lewis structures. So it's a lot faster than what we were doing before, but it has, and this is a type of trick you're going to see over and over again, it has information that refers you to something else to find. Oh, how many protons does this have? Well, let me look at my periodic table. Oh, it has 10. How many neutrons is that? 20 minus 10, so 10 as well. How many total electrons are there? Well, there's 10, and 8 of them are valence electrons. That's all we can see, is this neon with 8 valence electrons. That's all it's telling us. But that's usually all we need to know. So, we're kind of cutting out the stuff we don't need as frequently, but it's still there, it's just layered in, it's hidden. We're implying something instead of directly writing it. And that's a trick that you're going to see over and over again in chemistry. Okay, so we got one more video for this section. I'm going to talk about electronegativity and its trends on the periodic table. And then that'll be it for this. And then we'll start putting together atoms in the next section and making compounds.